Hello and welcome to another riveting adventure in algebra, and today we are talking about types of numbers. To talk about, categorize, and group numbers, we'll be using sets. So if you don't know about sets or you'd like to review sets, I will put a link up here, and you can go ahead and give that a click and get all the information you need to know about sets. So first we have the natural numbers. The natural numbers are the numbers we use to count. They're the non-decimal positive numbers. So the set of natural numbers includes 1, 2, 3, 4, and we continue counting all the way to infinity, and that's what those three dots mean. Next, we have the whole numbers, and the whole numbers are the natural numbers, and then we include 0. So the set of whole numbers is 0, 1, 2, 3, and we continue counting all the way to infinity. So let's take a moment to compare whole numbers and natural numbers. And we'll do that by picking a number. We'll pick 1. 1 is a natural number, and 1 is a whole number. And what about 0? 0 is not a natural number. It's not included in the set of natural numbers. And 0 is a whole number because it's included in the set of whole numbers. Now let's move on to integers. Integers are all positive and negative whole numbers. So integers include whole numbers. All whole numbers are in the set of integers. So we have all positive and negative whole numbers. We will create the set by starting at negative infinity, counting into -1, 0, 1, and then we continue counting out to infinity. So let's compare some numbers again. We'll choose 1. 1 is a natural number, a whole number, and an integer. And what about 0? We already said 0 is not a natural number. 0 is a whole number. And because 0 is a whole number, it's also an integer. So hopefully we can see how these sets of numbers are building off of each other. And for a quick review, we have natural numbers. They're the non-decimal positive numbers. The whole numbers include all the natural numbers and 0. And the integers are all of the positive and negative whole numbers. Next, we have the rational and irrational numbers. And this is where things get just a little bit tricky. So we have rational and irrational numbers. So we're going to represent rational numbers by x equals a over b. So a rational number equals the division of two numbers, a and b. And when we divide two numbers, we can we can express that as a decimal number. So we have a decimal number. Now that we have decimal numbers, so we have decimal numbers. Decimal numbers, there's two different types of them. There's ones that end, or we say they terminate, and ones that do not end. They do not terminate. And out of the ones that don't terminate, we have ones that repeat, and we have some that do not repeat. Numbers that end and numbers that do not terminate but repeat are called rational numbers. Numbers that do not terminate and do not repeat are called irrational numbers. So let's take a look at our rational numbers. we said our rational numbers can be written like this: x equals a over b, and a and b are integers. So an integer, let's try that again. An integer is a non-decimal positive or negative number. So let's try a couple out. First, we'll start with 3/2, 3 over 2. When we write this in decimal form, we get 1.5. And notice there's no numbers after this 5. And that means that this number terminates. So that's what terminating means. And now let's look at this number 5 over 3. In decimal form, we get 1.6's repeating all the way for an infinite number of 6's. And we can use this little bar to represent repeats. So we could write 1.6 repeats. So 1.6 repeats is never ending, so it does not terminate. But it repeats. And that makes it a rational number. So when we say repeats, or when we talk about repeating, we're talking about two numbers next to each other being the same. So if neighboring numbers are the same, the number repeats. Notice that we didn't care to mention terminating numbers and if they repeat or not. We don't care if terminating numbers repeat or not. Either way, they'll still be rational. So now let's talk about irrational numbers. Irrational numbers are non-perfect roots, non-perfect square roots, and special numbers like pi. So what is a non-perfect square root? It's going to be easiest if we describe a perfect square root, and that'll tell us what a non-perfect square root is. So we have perfect square roots. Perfect square roots, like root 25, equal an integer. So a perfect square root occurs when an integer multiplied by itself equals the radicand. And the radicand is this number here. It's the number that's underneath the square root sign. So a non-perfect square root occurs when there's no integer multiplied by itself that equals the radicand. So let's look at a number, root 3. So we'll figure out if there's an integer multiplied by itself that equals the radicand by considering all of the integers smaller than 3. So we start with 1. 1 times 1 is 1. 2 times 2 equals 4. And since integers can be both positive or negative, we have to consider -1 and -2 as well. 1 times -1 is 1. -2 times -2 is 4. So there is no integer multiplied by itself that equals 3, which makes root 3 irrational. And now special numbers like pi, in decimal form, pi equals 3.1415, and we continue listing numbers forever. And if we looked at this entire list, two numbers that neighbor each other, that are next to each other, will never be the same. And lastly, with irrational numbers, any multiple of an irrational number is also irrational. So say we have 2 root 3. So we have 2 times root 3. Because root 3 is irrational, 2 root 3 is also irrational. Or maybe we have something like pi over 2, because pi over 2 equals 1/2 of pi, 1/2 times pi, and pi is irrational. Pi over 2 is also irrational. So that's it for our rational and irrational numbers. Which brings us to the real numbers. The real numbers is the set of all rational and irrational numbers. So I drew this flowchart to help us see or visualize what we've just been talking about and make all of the connections of the different types of numbers. So let's take a look at natural numbers. Natural numbers are whole numbers. All natural numbers are integers. All natural numbers are rational numbers, and all natural numbers are real numbers. And how about whole numbers? All whole numbers are integers. All whole numbers are rational, and all whole numbers are real numbers. But not all whole numbers are natural numbers, because remember, the whole numbers are all natural numbers, including 0. So the only whole number, so these are our whole numbers. These are whole numbers. All whole numbers except for 0 are natural. 0 is not included in the set of natural numbers. So say we had a number, say we had 3. 3 is natural, whole, an integer, a rational number, and a real number. But 0 is a whole number, an integer, a rational number, and a real number, but it is not a natural number. And now let's try this with our integers. So for our integers, all integers are rational numbers, and all integers are real numbers. But not all integers are whole numbers, and not all integers are natural numbers. So say we have -2. -2 is an integer, a rational number, and a real number, but it is not a whole number, and it is not a natural number. So that's how we use that chart. The next chart that I drew up that I was hoping would be helpful is this guy here. And so we used this formula to describe rational numbers. We used x equals a divided by b. And for all of our numbers, a and b are non-decimal numbers, because we built whole numbers, integers, and rational numbers off of the set of natural numbers. And natural numbers are non-decimal positive numbers. Next, we look over here and we see that for the whole numbers, the whole, natural, and integers, b is equal to 1. So what does that mean? We have x equals a over 1. So say that we choose a equals 2, then x equals 2 over 1, which equals 2. Or maybe we say that x equals -2, or a equals -2, so x equals -2 over 1, which equals -2. And -2, what kind of a number is -2? -2 is an integer and a rational number, but it is not a whole number, and it is not a natural number. So we should not a whole number and not a natural number. So that's what that b over 1 means and how to use it. And here we have stipulations for a. It means what a can be and what a cannot be. So this should say a cannot be 0 for our natural numbers, because 0 isn't included in our set of natural numbers. If a was 0, we'd have x equals 0 over 1, which equals 0. And 0 is not a number, or not included in our natural numbers. And the set of whole numbers, a can be 0 or any natural number. For our integers, a can be a positive whole number or a negative whole number. And for our rational numbers, a can be any integer and b can be any integer. So hopefully that's something that can help you guys out as well. And lastly, we have a practice problem. So this problem is asking you to choose the different types of numbers from the set A. So first we want to choose the natural numbers from the set, and we'll just go one by one through them and see if they're natural or not. So negative 20 is negative, it's not natural. Negative 9 is negative, it's not natural. 1 divided by 3 evaluates to a decimal number, so it's not natural. 0.6 repeating is a decimal number, it's not natural. Root 2 is an irrational number. Root 49 is plus or minus 7, because 7 times 7 equals 49, and negative 7 times negative 7 equals 49. But we only consider this one, 7 times 7. And so root 49 is a natural number. 8.5 is a decimal number. It's not a natural number. Pi is irrational. 12 is a positive non-decimal number, so it is also natural. And 0 is not included in our set of natural numbers. Now, how about the whole numbers? Remember, the definition of the whole numbers is all natural numbers, including 0. So we have all of our natural numbers, and then we just include 0 in our set. So there's our practice problem. You guys go ahead and give the rest of them a whirl and pause the video, and then I will scroll down and show you guys the answers. So here are our answers, and our first note is that root 49 equals 7, so it is a natural number. All natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. And it's not an irrational number because it's a rational number. Next, we have 0.6 repeating. So although 0.6 repeating is infinite, it is also repeating, so it is a rational number. And lastly, we have root 2 and pi. Root 2 is a non-perfect square, and pi is never ending. So we get our irrational numbers are root 2 and pi. So I believe that is it for our discussion on the different types of numbers. I will post this cheat sheet in the comments. There will be a link to a Google Docs, so you can go ahead and grab that and use it if you'd like. Thanks for watching. If you like the video, be sure to like it. Share the video. If you have any peeps that need help in math or also need help with this topic, comment and let me know if there's anything that was confusing, needs more explanation, or maybe if you just want to say hello. And with that, I'll see you guys next time.